All right, what's up? Hutch here, and this is Module 12, Lesson 3, Area of Composite Figures. I'm not going to lie to you, this can be a little bit annoying. You got to crank through this. It's really a test of focus and your ability to decompose things into easier problems. You'll definitely want to use as many tricks as you can of identifying duplicate pieces that you can just like multiply together and things like that. Step one, though, is going to be identifying these different shapes. Okay, so we're going to want to have your formula sheet handy. And the reason is because to find the area of these shapes, you need to know what the shapes are. Okay, the way that they organize your PSSA formula sheet is all the two-dimensional shapes are on the left and all the three-dimensional figures are on the right, and then they randomly have simple interest, I equals PRT. So we're going to be looking at all of these here to figure out the areas. Okay, so let's go ahead and start with the first shape. Okay, you can see it has some parallel, so this side is parallel to that side, this one's parallel to that side. When you see two pairs of parallel, this is our parallelogram. So go ahead and write that. So it's P-A-R-A. You have the two L's that remind you of the parallel lines. L-O-gram. Okay. Next one is obviously a triangle. So let's just go ahead and write that down. Hopefully you know what a triangle is. And the next one is a trapezoid. I always picture it as like this cup that can trap something. Okay. And like underneath it is a little bug of some sort. I don't know. That's a horrible bug drawing. Okay, so a trapezoid, the characteristics of a trapezoid are you only have one pair of parallel sides. So this and this, but realize that could be rotated. So please don't ever look at a trapezoid and assume it has to be positioned like that. Okay. So we have our trapezoid here. Sometimes trapezoids can have like a straight side here and it going down like this. But again, it still has one pair of parallel. Okay. But it could be rotated any which way. Okay. So you spell that by saying trap, the letter E, and then zoid. Okay. I always used to pretend that there was a little zoid in here. There's our little eyeballs, and the zoid was this little like zoid character with feet. Okay, trapezoid. Anyway, all right, moving on. Obviously, this is a circle. Hopefully, you know that's a circle. All right, some of the pieces, though, to be aware of is you have a base, if you want to write that, and then height, okay, and that's what those symbols are. Same thing there. And this is just base 1 and base 2, which are the two parallel sides, and then obviously our radius, okay? When you're looking at a composite figure that they call it, you just want to see the two shapes. So if you look at this, what are the two shapes that you see? Okay, so again, I see two parallel, and that's it. Okay, so it has one pair of parallel. So this is a trapezoid. Okay, and then obviously this one we have a rectangle. Okay, and so there's formulas for each of those, and then you can just add up the two areas, of course. Okay, all right, so let's go ahead and try this out. When we have this funky composite figure, you do have to do some logical thinking. Okay, we can see the triangle here, and then we can look at the triangle formula, which is 1/2 base times height. But you are going to have to figure out some things like, well, what is the base? Well, the base is 4 inches, okay, because I see it parallel to it right here. Okay, and then what is the height? Well, the height is from here straight up to the top. It's not the angle. So I know this whole thing, and I know this piece. So if I subtract this, I'm left with my height, or my leftover. Okay, so you have to do some problem solving like that. So we have our 20.75 minus the 14.5, and we get 6.25. So from here to here is 6.25 inches. Okay, so I like to do that kind of stuff so I have all my numbers ready to go. Okay, now when we go here, we can go ahead and solve for the areas. So we need to do the rectangle first, which area formula is just length times width. And then the triangle is 1/2 base times the height. Okay, and they have it all set up for you, so let's just go ahead and type it in. Okay, so we have 14.5 times 4, and we have 58, but we know it's area, so we need to write units squared. So let's see what the units are. They're in inches, so we really need to always be marking that correctly. And then let's go ahead and do the triangle formula, which is 1/2 base times height. Okay, and so we have 0.5 times 4, which is just 2, times 6.25. And we have 12.5. And that's also inches squared. So now that we know the area of those two pieces, we can go ahead and add them together. So our 58 plus the 12.5, and we get 70.5. Okay, but that's a total area, so it's inches squared. Excuse me. So the area is 58 plus 12.5, or 70.5, and they wrote square inches. I like just writing inches squared every time. Okay. All right, so let's go ahead and try this. First step is identifying the two shapes. So what are they? Well, we have a circle, but in this case, it's actually half of a circle. So semicircle. So we're using area of a circle and area of a triangle. Okay, so let's go ahead and start setting this up. So what's area of a circle? Well, it's a semicircle, so area equals 1/2. Okay, or if you want, remember, you can do it all and then divide by 2, or you could do 0.5. Okay, but we have pi r squared. Okay, so however you want to organize that is up to you. Okay, so we have 0.5 times pi times r squared. Let's go ahead and substitute everything. So we have area equals 0.5 times 3.14 times a radius, and you have to look then, is this diameter or radius? Well, it's not written over here, it's written in the center. So this is our diameter. So let's find the radius, 1.5 divided by 2. Our radius is actually 0.75. Okay, so that's what we're going to use, is 0.75 squared. Okay, let's go ahead and plug everything in here. So we're going to go ahead and do our 0.75 squared first, because the order of operations dictates that. Then multiply by 3.14, then multiply by 0.5, and we get area equals 0. And I got to look at where we're rounding, 0.88. Okay, and then we have 0.88 and then we're doing feet squared. Okay, so let's just go ahead, and I feel like I need to double check that one time. Okay, so I'm going to go to here. Let's do 0.5 times 3.14 times 0.75, which is squared, and yep, okay, same thing. All right, so we have the area of the semicircle, okay, because it's the area of a circle cut in half. And then let's go ahead and find the area of a rectangle. So we look at the formula if you don't remember. Hopefully you remember rectangle, it's not that hard. So area formula is area equals length times width. Okay, so let's go ahead and set this one up. Area equals length times width. Area equals 2.25, and then what's the width? Well, we can see that it's the 1.5, right? And so this will be a nice quick one. 2.25 times 1.5, and we get 3.375. Going to the hundredth, 375 or 38, there we go. 3.38, and then this is feet squared. Now we're finding the total, so we just need to join those two together, and we get a total area equals, and we need to use the rounded amounts. Okay, so let's go ahead, and actually we could have left the bigger number and rounded at the end. So let's actually go ahead 3.375. It probably won't make much of a difference, but if we can keep it and be more accurate till the end, that's going to be our best choice. So we're just going to hit enter and answer plus 0.88, and we get 4.255. Okay, rounded is 4.26. So our area equals 4.26 feet squared. Okay, all right, so there you go. Okay, so a little bit of a process. Like I said, it's not the most enjoyable thing, but it's definitely something that will push your logical thinking and problem solving. All right, let's use the area formulas to find the area of only the shaded. So we're going to be taking the total and removing the white. Okay, so go ahead and explore the two shapes. So we have a what and a what, rectangle and a circle. So let's find the area of both, and then we'll subtract the circle. So I'm going to label my two pieces that I'm doing. So area of a rectangle is length times width. Okay, and so I'm going to set this up, and we're just doing 6 times 8, which we know is a quick one, 48 meters squared. Let's go ahead and do the circle now. So I'm going to label that real quick. Area of a circle, if I don't remember, I just look, okay, and it is 2 pi r squared. So we have pi r squared, area equals 3.14. Let me write that meter, times the radius, which this is our what? Our diameter. So our radius is actually 2 meters squared. So what is our area of our circle? Well, we have 2 squared times 3.14. So 12.56 meters squared. And we want to remove the circle. Okay, so we're going to subtract the 12.56. And let's get an official answer. So 48 minus 12.56. And we have area equals 35.44. Any rounding rules? Nope. And that is meters squared. Okay, and there's our official answer there. So here we go with example 2. Okay, you can try this out. We just want the shaded region. So we have our total shape, and then we're going to be removing the square inside. So go ahead and pause, and you can try that one out, or we can just go ahead and do it together. Okay, so let's go ahead, and I'm going to do the circle first. Okay, so we know area of a circle is pi r squared. So let's go ahead and write that out. Area equals 3.14. What's the radius of the circle? Okay, so we have to sort of explore this a little bit and see what's going on here. Okay, so if we look, okay, where's the center of the circle? Well, the center is right here, right? And is there anything showing a distance to the outside edge of the circle? Well, yeah, right here. This actual diagonal length in the square, right, happens to be 6 meters. Okay, so that's our radius, okay, is the 6 and squared. So let's go ahead and solve this out. Okay, order of operations says do the exponents first. So we have 6 squared times 3.14. And we have a final answer of 113, I guess not really final, 0.04, and that's meters squared. So this is of our circle, and you can see why it's so important to label things to keep track of what you're doing. All right, let's go ahead and do the square now. So we know the formula for a square, okay, is area equals the square, each side squared, okay? So let's go ahead and set this one up. So area equals, or it's side times side, or side squared, however you want to put it, okay? It doesn't really matter, okay? So S squared, okay? Area equals, what is the length of one of the sides? Well, we can see that right here, okay? So we have 8.5 squared, and this is a nice quick one. So what is 8.5 times 8.5? Well, 8.5 squared is 72.25. and that is meters squared. So now we have that, and you just need to pay attention to which one are you removing. Well, we want to know the shaded, so we're removing the square. So let's go ahead and subtract the 72.25 and get our official final answer. So area of shaded is 113.04 minus 72.25. And we get an area of 40.79. And again, I have to go back to my units of meters squared. Okay, so there we go. All right, try out the check here. They want the area of the shaded region. Okay, so you can look at a couple things. I guess my brain goes, well, I see a triangle here and a triangle here. Can I just find those two areas? Maybe some of your brain saw this. So maybe you see this shape here. And what shape is this? It has one pair of parallel lines. And so that's a trapezoid. So we also have a trapezoid minus a square. Okay, so it depends on how you look at it. If you can figure out the bases of everything, you really could just do 1/2 base times height. That's the area of a triangle. Okay, right here. You could do that for both of those triangles, okay, if you know the bases of each one and the height of each one, okay? And you probably, I don't know if you can figure that out or not, only because we don't see, we see the whole distance here of the 18. If I subtract this piece here, it's hard to tell what that's really removing because it's cutting out this weird distance. It's only like removing this. So it's hard to know what those two pieces really are. So I think we're stuck using the trapezoid. Okay, so let's go ahead and look at the trapezoid formula. Okay, it's 1/2 of the height times base 1 plus base 2. So let's go ahead and get the trapezoid first. So I'm just going to label this trap. And we're going to write the formula down. So area equals, okay, 0.5, I'm going to get rid of the half, times the height, and in parentheses, base 1 plus base 2, okay? And it's just the two parallel parts of the trapezoid. So let's go ahead and fill this out. So area equals 0.5. What is the height of the trapezoid? Well, we can see the height is right here. Okay, so again, I'm going to outline the trapezoid so you can see what we're looking at here. Okay, so the height is 15, and then we're multiplying that by base 1 plus base 2. So base 1 is 18 feet, and base 2 is 8 feet. Okay, so now we can find the area of the trapezoid. So let's go ahead and do that and type all of that in. Okay, we have to do the 18 plus 8 first, because order of operations says take care of all your grouping. Then we can multiply, here I'll put it in parentheses. Then we can multiply by 15, and we can multiply by 0.5 or just divide by 2, okay? And we end up with 195, and its area, so it's feet squared. So that's the area of the whole trapezoid. Now we want to remove that triangle, right? So what's the area formula for a triangle? Let's go to it and explore, okay? So triangle, okay, is area equals, and I'm just copying it down, 1/2 base times height. So let's go ahead and plug it in, 0.5 times the base, which is 8 feet. Okay, I can see that base right there. And what's the height of the triangle? Okay, the height of the triangle is 15 feet. Okay, so times 15. It's all multiplication, so I can just go left to right and plug it in. So we have 0.5 times 8 times 15, and we get 60. Okay, and this is feet squared. So there's our triangle. Which thing are we removing? Well, we want to find the shaded, so we're removing the triangle. So I'm going to be subtracting the triangle's amount, and we get a area of the shaded region equals what? So 195 minus 60, oops, and we get 135, okay? So 135 feet squared, And there you go. Okay. All right, now we're on to our apply. So let's figure out what we're doing here. Oh, look at all that stuff. My goodness. So the members of a local community center are planning on using ceramic tiles to create this mosaic. One tile covers 2.5 square feet. How many tiles are needed to make the mosaic? Okay. So this is one of those things where we're going to end up dividing up our answer to find out how many tiles we need. Okay, so let's first find the area of the mosaic. And I'm guessing the mosaic is this whole tan thing here. Of course, it's a funky shape. So one of the things that I see here is I see a rectangle. So we're analyzing this a little bit. I see a rectangle, and then I see all these little triangles here. And luckily, the triangles are all the same size. So if I can find the area of the rectangle and an area of one triangle, it's easy to multiply it by 4 and then subtract it. So let's go ahead and step 1 is just figure out how to tackle this problem. Okay, so I'm going to do area of a rectangle first, which is length times width. Okay, and I always do a little cursive L so it doesn't look like a 1. Okay, so area equals, we have 18 going up and down. It doesn't matter the actual length or width, just find the two sides. All right, and then we have the number 20 here. But if you look, it's not stretched out from here to here. So we got to be a little bit careful about this kind of thing too. I think this is 20, this is 5, this is 5. So the whole rectangle is 20 plus 5, which is 30. So I think this is our length and our width, okay? And then we have our area equals 18 times 30, and we get 540, and it's feet squared, okay? And this is, remember, we want to label things. This is my rectangle, okay? So now let's do those little triangles. So I'm going to label here, and I need to remember the triangle formula. Do you remember what it is? It's right here. Area equals 1/2 base times height, okay? So I have 1/2, or you could do area equals base times height divided by 2. Same thing, okay? All right, so let's go ahead and plug this one in. So area equals, and then let's analyze one of the triangles, okay? We know that let's see. All right, we know that the base is 5. Okay, now we got to figure out what the height is here, okay? So we know this whole thing is 18, okay? And so the whole thing is 18. We know this amount is 10. So 18 minus 10 is 8. And we know it has to be split evenly. So we have a 4 and a 4 here, okay? And so that's what we end up with, okay, is a 4 here, and that adds up to the 18, okay? All right, so we have a base of 5 and a height of 4, and that whole thing gets split in half because a triangle is just half of a rectangle, okay? Let's go ahead and plug that in and get our area of our rectangle. So 5 times 4 is 20, divided by 2 we know is 10. So we have 10 feet squared for each rectangle. But how many rectangles do we have? We got 1, 2, 3, 4, right? So we got to multiply that by 4, and we end up with an actual area of 40 feet squared worth of worth of triangles, okay? So let's get rid of the triangles from our rectangle, right? And subtract 40. Nice, easy math on this one, huh? All right, so we have a total area of 500 feet squared because we took our rectangle and subtracted all our triangles. Now, we're not done, so be careful. It says if one tile covers 2.5 square feet, how many tiles do we need to make? So we need to take this, divide it up into the 2.5, because that's one tile, to figure out how many tiles we actually are going to need to fill this. So 500 divided by the 2.5, and it tells us that we need 200 tiles. So that's not how you spell we, we need 200 tiles. Okay, so this is a lot about just understanding what they're asking and then problem solving through it. Okay, here's your check. Let's go ahead and tackle this together, and then you can work on your practice. I really shrunk down your homework, so don't get too worried here. It's just the 4 problems instead of a whole page of stuff, and then the apply. Okay, so let's go ahead and try this check together just for some more practice, because this is a lot of pieces. They're creating this weird walkway. Jameson hired a landscaper to do this. I don't know why. That's a horrible, sad thing if we have to calculate all this, but whatever. All right, so here we go. In one case of decorative stone, if one case costs $25 and costs 6 square feet, how much will it cost to cover the driveway? So we first have to find out how many cases we are going to need. And then if each case is $25, we have this extra piece here, right? Okay, so trying to understand what's going on is key. All right, so let's start looking at some shapes, okay? First thing that I see, okay, well, that doesn't work, right? Can we break this here? Yeah, we could break that. I could go this way and end up with these little triangles, but it doesn't mean that I necessarily know what these lengths are. So I'm guessing, let's see if we can do the trapezoid and the rectangle. So we know the base here, we know this base of the trapezoid, and we know the height. Okay, so I think we're good with the trapezoid. We also know the length and the width of this rectangle. So this is going to be our key, okay, is identifying the 2 shapes as trapezoid and rectangle. So let's go ahead and do the trapezoid one first. Here's the area of a trapezoid. So again, we want to make a mark here of what we're doing to keep ourselves organized. Okay, so we have area equals, and I'm just going to do the divided by 2 thing. Height times B1 plus B2, and all that is cut in half, okay, or 1/2 of all that. Okay, let's go ahead and fill this out. So what's the area of the trapezoid? Well, our height is 4.2, okay? Base 1, you can pick any one, it doesn't matter, 13.65, and the other base is 4.2, okay? And then that whole thing needs divided by 2 to get an official answer. So what is the area of the trapezoid? Let's go ahead and plug that in. So we have 4.2 times 13.65 times 4.2, and all of that, I'm going to say answer is divided by 2, okay? And we end up with an area of 120, and let's leave the full decimal for right now, okay? What's the units? It's in feet squared. So there's my trapezoid. Let's go ahead and do the rectangle, okay? We know that rectangle formula is area equals length times width. So let's go ahead and plug this one in now. The length is 6.3. The width is 4.2. Nice, easy area problem. Area equals 6.3 times 4.2, and we get 26.46. Okay, and that's feet squared because we're doing areas. Okay, so what's the total? Well, let's add them together. Okay, and so now we can write total area equals, and I can just hit answer plus 120.393, and we get a total area of 146.853. 146, I already forgot, 0.853, and this is feet squared. So there's our total area. Now, a case of stone costs $25, okay, which is fine. We just don't know how many cases we need. A case only covers 6 square feet. So let's find out how many 6 square feet are in here, but by dividing this whole thing by 6. So we'll take our answer, divide by 6, and so we're going to need 24.4755 cases, but think about it. Can you get 24.4 cases? No, you're going to have to, if you get 24 cases, you don't have enough. So how many cases are we going to need? Well, we need 25 cases, okay? So we can just write 25 cases, okay? Now, how much does each case cost? Well, each, which means multiply, cost $25. So what is the total cost? Well, we have 25 times 25, and that's 600. So how much will cost? It will cost $600. So lots of work there, okay? But if you slow down, take your time, you definitely can figure it out. All right, so here's your practice and homework for today. You can see you have the semicircle there and rectangle. You have two triangles. You have some decomposing of stuff, okay? Looking at a total and then removing pieces, okay? But they're not too bad there. And then one apply that's very similar to the applies that we just did, okay? All right, so go ahead and take a look at those. And if you need any help, let me know.